rumble? Here we go, we're rumbling. Okay, so we need appropriate comment. Alright, so we treat it just once again like we do normally completing the square. We need the a value to always be 1. So, here we go. 2x squared plus 20x minus 4. That's what we did on the last one, didn't we? We separated the last term. Now, we still have an a value of 1. I need to factor out the 2. Even if he doesn't go with the 20, you have to factor the 2 out of the 20. What if that guy was a 5? You still have to pull him out? Yep, you do. Those aren't fun, I'm telling you right now. They're not. But it is what you have to do. Okay? Alright, so first off, I gave you a nice one. And when I pull out the 2, is it still nice with the 20? Yeah, it is. Okay. It's nice. So, we're starting out easy. So, 2x squared plus 10x parentheses minus 4. Everybody there with me? Maybe have a question there. Yes, sir. That's what factoring out means. It's pulling out what they have in common and then dividing them and stuff, correct? We don't ever play with decimals. Okay, here we go. So, notice, ladies and gentlemen, that middle number is 10. What value completes the square? 5 completes the square? 25 completes the square, correct? I need to put a 25 here because notice half of 10 is 5. 5 squared is 25. That pattern is, right? Take half of him and then square it. Okay. I put a 25 there, so what goes out here? No. It's called 50. Oh, because truly, ladies and gentlemen, let me hear you show you. If I distributed this through, this would be 2x squared, same as above. 20x, same as above. 2 times 25, goes from here to here. What's the difference? It's 50, huh? Not 25. Because the number I had to pull out. Okay? So because I put a 25 here, but truly because of this 2, that's technically a 50, right? So for me to balance it, I need to subtract 2. No, we're good. Watch. Continuing on. Okay, so I'm going to erase this stuff down here. Okay. So I erased that. Now, I do not still have a number in front of the x. No. What I did have there, sir, was I was truly saying, what did I truly add to my equation? Was it truly 25? No. It was truly a 50. On the ones that we've done previously, why did I always just do the opposite of what it was? So I put a 9, and so therefore then I put a minus 9. Because what was the number always out front? A 1. And 1 times 9 was 9, right? And so therefore, for me to balance it, I just subtracted 9. Because that balanced it out. But with us having a number out front, that truly affects it by doubling it. Because if I distribute it through, that tells me the difference from my original equation to where I'm at right now. Does that make sense? I'm telling you right now that is the biggest mistake people make. Is right there. They forget. Go ahead and see if that's the number that you see. That is a check mark, a double check mark. That's a checkpoint. Make sure that you are doing the right number. Subtract it. Okay? Alright, so now we're in a perfect square trinomial. By the way, this is still y equals. So let's now write our equation in vertex form. Okay? Vertex form would be y equals 2. What does this trinomial become? X plus 5 squared, right? Because that was a perfect square trinomial. So a perfect square trinomial goes down to the binomial squared, right? And then what's negative 4 minus 60? There you go. my vertex? If I ask you for my vertex, what is my vertex? Positive 5 or negative 5? Negative 5 on the negative 54 would be my vertex. Why is it negative 5? Is that what you're asking? Once again, if you recall, here's our vertex form. Y equals A, x minus h quantity squared plus k, right? Where hk, Brandon, is my vertex. Notice h is the value after the minus sign, correct? We're looking here, isn't this x minus a minus 5? Isn't the negative negative a positive? So therefore, what is after the minus sign? Negative 5. Does that make sense to you? Anything on the inside of your parentheses is opposite of what you see. Didn't we do shifting with you guys? Did we talk about parent functions and shifting? Well, we'll get that here. Okay, there's example number 1. Try another one? Yay, we are. I'm going to make it a little bit harder, but not too much, not with a fraction yet. Okay, so we're going to play around. Okay, here we go. Example 2. Y equals negative 3x squared minus, let's do a plus actually, 12x plus 1. I would like you guys right now to start to try, because once again, if you can't do it on your own here, it's going to be harder. I know it's practice, but I'd like you guys to separate it and make it look like this. We're going to click pause. Okay, so we're back on. We should have had time. So here's what the goal is. Once again, let's see if you can see. Hopefully everybody tried. Okay, hopefully everybody tried, because that's the key thing. Now maybe you can see where a mistake is, or you can see what your thought process was. So, here we go. First step. Group them together, right? Just like we normally did with our coefficient being 1. Now, notice I'm giving myself some space, right, in my parabola. Please do so. First thing at stake, I guess that's the first thing. What's the second thing? Factor it out. Even if he doesn't have it, you have to factor it out. Okay? In this case, they both share 3. So I'm being nice again, right? Are they always going to share something? Okay, so I factor it out to 3. X squared, because if I pull the negative 3 from negative 3, that's square. 12 divided by negative 3. Negative 4x plus 1. Have I changed the value? I've still not changed the value, have I? Made it look different. Melania, what goes into square? It is 4. That is the value that completes the square. Let's make sure we understand why it's 4. Melania, how did you get 4? Square rooted. Okay, so you went in and took half of him, right? Half of negative 4, the middle term. Took half of negative 4, and then you squared it. So half of negative 4 is negative 2. Negative 2 squared is 4. Okay, everybody there with me? James, what did you put on the outside? The balance of that. Did you not get that? Okay, let me help you out. Anybody go on? I saw. Okay, go ahead. Okay, where'd you get a minus 8 at? Where'd you get a 2? Okay, I understand that. But notice, remember, that was the last time it was doubled because there was a 2 out front. Do we have a 2 out front? What do we have? A negative 3. So when I distribute through, negative 3 times 4 gives us a what? Positive. This is really a negative 12 right there in our long scheme of the equation, isn't it? If I distributed through, that would have been the difference between this guy, the vertex one that we're at, and the original standard form is the negative 12, correct? So therefore, for me to balance it, I need to add 12. Does everybody understand where the plus 12 comes from? James? Melania? No problem. So once again, Melania, go here. If I come back to its original problem, that means I have to distribute that through, right? So I have negative 3x squared. Negative 3 times negative 4 is a positive 12x. Negative 3 times 4 is a negative 12. Put that guy right there. Okay? And then notice the green was the plus 1. So when I completed the square, what's different from this guy and that guy? Looking at the exact same thing. We still have a negative 3x squared. We still have 12x. Yes, we do. We still have a 1. Yes. What did we add? We added the negative 12. So for me to balance it out on the same side, what do? I add 12. Right? So therefore, that's where this guy comes in. So on my teeter-totter story, that means somebody took a baby off with minusing 12 pounds, and then what happened? You put a twin baby that was 12 pounds back on. That's my teeter-totter. Love you, Bruce. Okay. Okay, so coming back to this guy right here, we are now putting him in vertex form, correct? Okay, so we put it out. By the way, it's a y equals. Y equals. My negative 3's out there. What does x squared minus 4x plus 4 become? Because now it's a perfect square trinomial. It becomes x minus 2 squared. Great job. Okay? What does the outside become? 1 plus 12 is 13. Ladies and gentlemen, what is my vertex? If I ask you for my vertex, vertex is 213. You've got to get in the habit of not looking at that negative. It's opposite of what you see, because remember, it is x minus h, and h is the value we're looking for, right? Okay, we okay on that one? Onward and ever onward. Example 3. Need a little tougher on it. So I need to y equals 4 x squared plus 10x minus 1. This one's not so pretty, so we're going to go together as a class. Piece by piece. Okay? Ladies and gentlemen, this guy's going to have a fraction. Do not get scared of a fraction. It's a fraction, people. You're bigger than a fraction. Squish it like a bug. Okay? Your mind can handle these. You guys just got to let it handle it. Okay, first step. What's our first step? Separate it, right? 4x squared plus 10x. When I pull out the 4, is it going to go into it evenly? Not. Okay? It's not going to go in evenly. So here we go. We still have to pull out that 4 no matter what. That 4 is there. I cannot complete the square with that 4 being there as my coefficient. I have to have a 1. Okay? Everybody with me? Factor out the 4. Brady, as you said earlier, what does factoring out mean? We times, we subtract, we add, what do we do? We divide out. So what's 10 divided by 4? 10/4, which is the same thing as 5x. Anybody have a question there? Once again, overcome it, persevere. Don't stop because it's a fraction. Okay? Now, what's the next step? What do we do previously? We complete the square, don't we? Right? Stuart, do you know what's half of 5 halves? I took 10 and I wanted half of it, I times by half, which is 10 halves, which is 5, right? What's the number I have? 5 halves, right? I want to times it by a half, or cut it in half, so therefore that number is 5/4. Anybody have a question on how I got 5/4 as being my half value? All you got to do is take the number and times it by a half. That's all you do. That wasn't bad, was it? So once again, you get scared of a fraction. Don't be scared of a fraction, okay? Don't be scared. Okay? Notice, then what do? If I took half of that 10, we got 5, what would we have done if it was 5? We squared it and we would have got 25. Well, how do I square a fraction? Just square 5/4. 5/4 times 5/4 is 25/16. That's what it is. Oops, let's put that in a color here. That is what I added to my equation to make it work. Okay? Mr. Hanson, you okay? Anybody have a question? Don't let a fraction scare you. No problem. Okay. You ready? Who asked this question? So, are you okay with the 4 pulling? You understand how I got the 5 halves? Okay, so when we factor out something that's like dividing out, so for example here, if I had 4x squared plus 8x, and factor out the 4, that's 4 divided by 4, which is 1x squared, right? How do I get this number? If I pull out a 4 from him, that's technically 8 divided by 4, which is 2. I just divided. I know, right here. So first off, we got to make sure you know how to get the 5 halves. So I pulled out the 4 from 10, so that's 10/4, reduces down to 5 halves. Now remember, to complete the square, I got to cut this guy in half, right? So here is that part. 5 halves times a half is 5/4. With that, 3 in, right? Okay. With that, after we cut that guy in half, we have to square it, right? Isn't that the process of making square? Notice looking at our previous example, we cut this guy in half and then squared it. Half of -4 was -2, -2 squared was 4. So now I'm just doing it, but I'm doing it with a fraction. So 5/4 times 5/4, let's go straight across. 5 times 5 is 25. 4 times 4 is 16. Are you okay there? Everybody okay there? Okay. Now, what number did I truly add to my equation then? So what do I have to do to tell this? I have to times this 4 to that 25/16, right? So I technically have 4 times 25/16. Does anything cancel out there or reduce out? 4 and 16 both have a what in common? 4. So now I truly added what? 25/4 to my equation, didn't I? Simon? Let's take a look, you okay? Because didn't I previously took the number, let's say this guy was a 7. I would go 4 times 7, which was 28, right? And then I subtracted 28 out of it. Well, I got to go 4 times the 25/16. 4 times 25/16. Me personally, I was always taught to reduce first before I times across. 4 and 16 both have a 4 in common. So I took out the 4 of him. There's a 1 there now. And because I took out a 4 out of him, there's a 4 there. 1 times 25 is 25. 1, because there's a 1 under there, times 4 is 4. So that's truly what I added to my equation. So what do I put out here by the -1? Minus 25/4. I'm going to erase this stuff. Hopefully on the notes, if you ever watch it, it'll be there. You'll see that I erased this stuff. I'm going to erase this because okay, so, whoops. done? Now I just need to finish it up. Okay? Here we go. Last step. Y equals 4. What was my half value of this whole thing? 5/4, right? That was my half value. So is that x plus or x minus 5/4 in my equation? Plus because again, right? Because of the 5 halves. Positive quantity squared. What goes on the outside? What did you say? How did I get 5/4? 5/4 came from what's in. Remember, it's always a half value, right? What was half of 5 halves? It's the 5/4. Remember that on the side that we did over there? You're okay now? So, Adam, how did you get 29/4? Did I get 29/4? Common denominator. When I add fractions, I gotta have a common denominator, right? Some of you guys are losing it. Make sure you stick with me. Okay, so this becomes 4/4. Isn't 1 the same thing as 4/4? Right? Combine like terms, because they're a common denominator, that's negative. Not combine like terms. Subtract the fractions, because now I have a common denominator, so that's negative 29/4. Now that one wasn't fun, but it's not as bad. It's long and tedious. That's why you guys don't like fractions, is because it takes extra steps. Let's be honest. That's why. Not because there's, if you know the 4 things or 3 things about fractions, when we add or subtract, what do we have to have? Common denominator. When we multiply fractions, what do? Straight across. When we divide fractions, we times by its reciprocal. As somebody told me the other day, skip, flip, and multiply. That's the 3 rules. You know those 3 rules? Fractions are a cake. Are they a little bit longer and more tedious? Yes, they are. That's it. Okay. Really, right now, I want to show you the quadratic formula where he came from. Okay? Because I'm going to show you how to solve really quickly. Now, I don't expect you to take notes on this. Okay? This is just a proof of where the quadratic formula came from. Ladies and gentlemen, we have y equals ax squared plus bx plus c. Just stand in amazement of how this works. Okay? That's all I'm asking you to do. Notice, guys, we're going to solve by completing the square. Okay? So, notice I have ax squared plus bx plus c. Is everybody there with me? First step you do, guys, is what? Take out the a, because that's not a 1, is it? That's an a value. Does that make sense? So we have to take out the a value. So when I take out the a value, I get x squared plus b over ax plus c. Okay, there. What was our next step to complete the square? We cut that guy in half, don't we? What guy are we cutting in half? B over a, right? So if I cut b over a in half, that times it by a half, so that is b over 2a. So therefore, for me to fill the spot, I have to square this, right? Isn't that the form? I take the guy, cut him in half, and then I square him. Cut him and cut, can't even talk. Square this guy. That becomes b squared over 4a. Because I square the top, b squared. Square the bottom, 2 times 2 is 4. A times a is a squared. Oops, I didn't put a square. Anybody have a question there? What did I truly put there? Well, a times this stuff, a times b squared over 4a squared. Notice, ladies and gentlemen, that a gets rid of one of those a's, so that's b squared over 4a. So therefore, I truly put a b squared over 4a, so to do it, I have to minus b squared over 4a. Now you're like, what the heck's going on. It's okay. Take a deep breath. I'm not expecting you to do this. It's just interesting where it comes from. Okay? You might be saying, no, it isn't. But yes, it is. It's this. Okay. So y equals this. All right. So now I got to go ahead and complete the square. So that is now y equals a x minus b over 2a quantity squared. Now I need to get a common denominator here. So therefore I put 4a and I times 4a. So notice this is 4ac minus b squared all over 4a. Alright, there's completing the square. That's it. That's the answer. You're like, what the heck? Okay. Well, that's it. But then they ask you to solve for x. So I need to solve for x. Okay? That means they're looking for their zeros. That's when y is 0. Okay? Stick with me, guys, even though. Just look at it, just be in amazement still. So I put 0 in. I get a. X minus b over 2a quantity squared plus 4ac minus b squared all over 4a. So I want to get to here, so I need to subtract him over. Okay, the 4ac minus b squared. I need to subtract him over. So when I subtract him over, I get negative parentheses 4ac minus b squared over 4a equals a x minus b over 2a quantity squared. Now what happens here is I have to distribute that negative through. So that becomes negative 4ac plus b squared, or b squared minus 4ac all over 4a equals a x minus b over 2a. I got 2 more steps, guys. We're almost there. Stick with me, Macy. It's like, why do I care about this? But it's cool. Okay, how do I get rid of this 8? We divide it, right? When I divide it, I put an a down here to make him a square. Because if I put him downstairs, it's just still downstairs. A times a is a squared. Does that make sense where that comes from? Okay, so here we go. So now I'm at b squared minus 4ac, that's part of our quadratic formula, isn't it? Over 4a equals x minus b over 2a quantity squared. How do I get rid of a square? Ah! How do I get rid of a square? Yes, ma'am. Thank you. How do I get rid of a square? Square root it. So I take the square root of both sides. But remember, when I take the square root, what do I have to do? Plus or minus. So I have the square root of b squared minus 4ac with plus or minus out front. And the square root of 4 is 2. The square root of a squared is a equals x minus b over 2a. Hold on, this should be a plus, gosh darn it. All the way back up there. I messed up all the way up again. Yep, that should have been a plus. Plus, 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 plus. Sorry. Plus, plus. There's something wrong. Then what do we do? How do we get x by itself? We subtract that stuff over, don't we? Ladies and gentlemen, here's the quadratic formula. X equals negative b over 2a plus or minus square root of b squared minus 4ac over 2a. Because they have a common denominator, I can add the top to get x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And that's how they got that formula. Now you guys don't even appreciate that, do you? But it's pretty cool. Like, they gave you something, right, from a generic form of ax squared plus bx plus c so that you could solve any gosh darn equation in that form by doing this formula. realize when it's with numbers, are you going to have as much of this stuff everywhere else? You're not. Okay? So, here we go. So, let me make sure, okay? I'm going to try to be nice, but I can't guarantee. I want you to solve by completing the square. Okay, now, Brady, beforehand, could I add stuff to the y side on my teeter-totter? Could I? Well, that's why we had our teeter-totter with the baby idea. We couldn't add things on both sides. Because this time we don't have a y, do we? No. Okay, we're just going to solve for a. So, here we go. First off, we need to still separate. So I have 4a squared minus 8a. This 6 is not going to be part of it, so I'm going to subtract him over. Okay? So therefore, I'm at negative 4. Have I changed the value of my equation? Yes. No, I have not. Ready? Guzman? Okay. What's our first step? We pull out the what? We pull out the 4, don't we? Have I changed my equation from doing that? Because I pulled out the 4. If I pull out 4 from negative 8, what do I get there, Brady? Factoring out. Okay? Is everybody there? Now notice, guys, I need to complete the square. So what I want to do first is cut him in half, right? Everybody there with me? Cut him in half. What's half of negative 2? Negative 1. Negative 1 squared becomes 1. So I put a plus 1 there, huh? What value did I truly add to that side? 4. Now when I have both sides, I added 4 to this side. Right? Got heavy. What can I do to this side now? Because there's not just a y. I can add 4. This time I can just add both things on the same side. Now why previously could we not add them to both sides? Because we wanted an equation with y by itself. So I couldn't add 4. If I added 4 to this side, I couldn't add 4 over here because I want a y by itself, didn't I? Does that make sense? But do I have a y? So I don't care. I can add the 4 to the other side. Is everybody there with me? This 4 right here, I got the 4 from 4 times 1. Does that make sense to you? I distributed, yes, sir. Okay, so we complete the square. So I have 4. What does this become in the parentheses? A minus 1 squared equals 0. Gave you guys a nice one as a miracle. Okay guys, now all we do is solve. So I want to get a by itself. How do I get rid of this 4? By dividing. So I divide by 3. What I do to one side, I do to the other, correct? So now I'm at a minus 1 quantity squared equals 0. Now what? How do I get rid of the square? I need to square root it. When I take a square root, what do? Plus or minus. What is the square root of 0? Is there really such thing as plus or minus 0? How about as if it was a 1? Is there such a thing as plus or minus 1? Yes, there is. So this would be 0 equals a minus 1. And therefore, what is a? There it is. So her question was, could I do it as separating the 0 first? Yep. I would subtract that 4 over. I mean that 2, and that 2 made 4. Sooner or later, depends on the problem. Either way, you're still going to add something to the other side. So, okay, ready for another one? Melania? Right here? Okay, remember, the perfect square trinomial, right? What's half of -2? What kind of one? And what do we do to get the perfect square trinomial? Then we square that, right? What's -1 squared? 1. Okay, last one. Okay? Let's see. All right, here we go. It is what it is, guys. I'm trying just to make it okay and work. Okay, I understand this isn't fun, but it is what it is. Yes. Try it silly. So that means what? Subtract the 2 over, right? Okay? So that's the way she wanted to do it, by subtracting the 2. So basically, we're there. And we still complete the square. Okay? So, my first step is pull these guys out. Everybody there with me? Okay, what's our next step? Stuart, what would you do next, buddy? Pull out the 5, right? What is it going to become? -6x. What value goes in there, Aubrey, to complete the square? 9, because we take half of -6, which is -3. -3 squared is 9. Ron, you okay with that? Okay? So what value do I need to, technically I added what to this side of the equation? So what can I do to the other side of the equation? Or I could put, you guys want me to put it on the one side like we've been doing, or put it on the other side? I'm going to put it on the other side. Okay? So, I need to add 45 over here. So, I am at now 5x minus 3 quantity squared plus 5 equals 45. Okay, now we start to solve for x. You always want to get this guy by himself. So, how do I get rid of him? Not yet. Subtract your 5 first. So I go 5x minus 3 quantity squared equals 40. Now what do I do, Jim? Now I divide by 4. How do I get rid of the squares? And when I do a square root, what is the square root of 8? Does anybody know? Without a machine, because I don't want the machine. What is the square root? 2 squared is 2, because 8 is 2 and 4, 2 and 2, that root of 2, right? So you have x minus 3 quantity squared equals plus or minus 2 root 2. Last but not, oh, no squares, no squares. You're just square root, right? Last but not least, what do we do? 3. X equals 3 plus or minus completing the square all the way with solid. The rest of that worksheet is yours. I love you all. By the way, after you leave today, I'm going to put something on this. If you would like to go ahead and get online and look for it, I'll give you extra credit point on your homework. If you draw this symbol and put it by your name, you will get the extra credit point. Thank you.